Okay, we're back with part 2 of the lab for week 10, the AC. And let me just continue. I'll bring up the experiment. Here's that you have. And we're doing, part 2 has 2 pieces, an AC and a DC portion. This video is just going to be about the AC portion, this page right here. Now this is a simple series circuit with some resistor values. We've done this circuit many times, both with resistors and with light bulbs. We've always had a DC source over here. Doing the usual thing, here's a table to do your calculated values. Let me just say, since I've seen it from you a lot, in a series circuit, I remind you, the current in every element is the same. So when I calculate current, it's the same for every entry here. Now, how do I calculate current? I use Ohm's law, but I don't know what the voltage is on each of these resistors because they're going to share the current, have the same current, and the voltages around here, the sum of them will equal the source. So I've filled in for you the values that are fixed. These are the resistor values. That's the voltage of the source. Kirchhoff's law says if I add these 3 voltages, they better be 2. And if I add these 3 resistances, that will give me the total resistance. So I calculate current by using Ohm's law on this voltage and this resistance. That gives me this current. Copy it right back up into these. Got to get that. Series circuit, every element gets the same current. Sum of the voltages around the circuit has to be 0, which means these voltages aren't all going to be the same. The power over here is just the product of these 2 columns, voltage and current. So I'm going to let you do that with those values, and I'm going to concentrate on taking the measurements. Now I'm going to do this in 2 parts. The measurements, like it says up here in the instructions, the measurements you're going to take with a multimeter, and I've got a multimeter like you had in lab, but a little more upgraded version. And if I'm able to get kits out, this is what you'll get. So I'm going to take a few moments to explain the basic measurements and the basic hookups that we've done. So in this multimeter, it's by a company called Proctor. Got these on Amazon. I think they're pretty easy. There's the usual control that rotates the dial, shows you all the possibilities. In this one, for AC and DC, you don't have to keep finding a different location for it. You just flip the dial, like I'm going to flip it here to volts. And you may not be, whoops, I'll find it up on the camera. And if I push this little blue button, you see where in the upper left it says auto DC. If I flip it, it will go to AC. Flip back, it goes to DC. So that's how you change between AC and DC on voltages, and again over here on currents. The currents, you do have to select the range, whether it's amps, milliamps, or microamps, and that's because things are fused, and you're still stuck moving the red probe over here for those. Okay, so we've got that as a meter and a couple of basic things that I'm throwing in there on that. We can use it right away to measure a couple of the resistors before I apply a power supply. So here's the probes. I'm just going to flip it up to here to resistance. And I have to push the dial to tell me that'll measure diodes. There's the open loop feature you're used to seeing. Here's something that turns on the sound. So I'm going back and just pick the resistor. Okay, and I'll measure this. I can just take, here's my circuit board. Whoa, kind of shiny there. Wow, you can hear, there we are. And here's the 3 resistors. Here's the 2.2, the 3 red ones right there. And this one is the 5.6 on the bottom. And the other one up here, whoop, if I can get my pointer right, is the 3.9. Okay, now I'm going to measure them to see what they really are, but these are the ones you'll calculate on. They're the ones you've got over here. Whoops, I can't get to it. Over here in the chart. Okay, so I'm just going to measure a couple of these. I can tilt this down a bit, and maybe not enough to see too well. I'm just going to tell you. So I'm going to measure the one that claims to be 2.2 K. Let me move this to where you can see it better. All right. So I got what? I get, let it do its thing, 2.176, and in fine print down in the lower right it says kiloohms. So that first measurement there for R1 is 2.176. Yeah, you can fill that guy in right there. 2.176 kiloohms. Okay? And I'll do the others, and you can follow up those. The next one is supposed to be 3.9. Let's see what we get there. 3.83. Now, for these cheap carbon resistors, these are not bad values. I just plucked them out of the cans like you're used to doing at school and got some good values. So here's the last one down there, 5.52. So instead of a 5.6K, it's 5.53 or something like that. So these are pretty good, well within the 10 or 20% tolerance. I think they're just 20%ers. Okay, so that's our resistor values. Now I'm going to have to set up and put the waveform on out of this guy. And give me a moment to adjust the camera and so forth, and we'll do that. Okay, so I'm back, and let me bring up the Pico scope itself, which I've left set up from last time. And you notice we're at 1 kilohertz and 2 volts here. And that's what we're seeing in the blue line, 2 volts. That's the peak, which is what we were told to set it at. The peak to peak is 2 volts. And there's no offset and so forth. Okay? And this is 1 kilohertz. I just left it set up from last time. But you can see it right here. It's set. Okay, now I'm going to attach it. That's the first thing. I've got a little fancier set of wires than we're used to, so I can both view it and attach it. And I'll put the black on the bottom and the red on the top of that circuit. So I attached it exactly the way the picture is drawn. And one thing you'll notice, the amplitude dropped just a tiny bit from 2 volts, and this changed scales, and that's going to be okay. I'll explain that to you. It has to do with the fact, I'll just say simply, this power supply also has a series resistor inside of it, and it's not the usual 50 ohms. And so it actually steals some of the voltage from these other three, but not much. So now I want to go measure some voltage. At least I want to look at them so you can see before we do the multimeter measurements. So I'm going to make some measurements now, but they are not the ones you're going to fill in here. I'm going to measure a couple of voltages. It is not these. If the instructions tell you to do these measurements with the multimeter, I'll do that in a minute. So now I have a choice. Here's my measurement channel B. I've got a black and a red. You cannot use the black, right? You can't use the black because this black is attached to this black over here in measurement, and that's attached to all of these ground ports here and right back to your computer. This is a similar situation to what you have in commercial and residential installations where you've got 2 wires or you've got a bunch of lights or motors or some fixtures, and the temptation is, well, just go in and measure them. Now you get away with that on the multimeter because this black has no relationship to this black or that black or that black. So you got to pay attention in real life to where the grounds are. And so, but in this case, the scope is already grounded, so I'm just going to let that one lie. And I'm attaching the positive lead here over to this point right here. Right, so I'm going to measure, I'm not going to measure the voltage across this. I'm measuring the voltage between this ground and wherever I put the probe, which is right here. So I'm measuring the voltage across these two resistors. And since they're both large, I'm probably going to see most of the voltage. So let me turn on part B, and I'm going to put it on a 2-volt channel as well. So here you see it, 2 volts. It's the red line. And it's on the same scale as the blue. Here's what's actually the difference between blue and red is the difference between this voltage off the signal generator and the voltage right here. Okay? So that's the voltage, the AC voltage across the 2.2 volt K resistor. It's not what the multimeter will measure. Let me move it over one, and let's see what happens if I go over here. Whoops, now to, I moved the red probe over to here. So now I am legitimately measuring the voltage across the 5.6 K. And it falls to just below half. And I would expect that because this 5.6 K is what? A little bit bigger or so, a little bit smaller than the sum of these two. All right, so that's kind of how that goes. But that's not what goes in this table. I'll set that aside. And we don't even need this oscilloscope on. We know it's powered up. Now the goal is we got to get in with the multimeter. I'm digging out the probes here and get this. And what are we going to measure? We can measure the voltages. We can start with those. They're easy. I've got 2 free probes. I can kind of do what I want there. So let's at least fill in the voltages here first. Okay, so I'm going to put this on volts, and I'm going to select what? AC. Now let's just see what I get. I'm measuring, I'm just going top to bottom in the table. So now you can fill out the table. Here's the voltage across the 2.2 K. And what does that come up? 0.25. Right? So I'm just going to put that in there. 0.25. Right? And I'm going to, didn't want to go up. I'll go down to the next one. I should be complete and put in volts. Let's do the next resistor. It is 0.44. You don't need that third decimal point too much, so it's 0.441. You saw that there. And then I'll go to the next one at the bottom. And it is 0.637. 0.637 volts. And then I'm going to measure the whole thing. So I'll measure across everything. And I get 1.33. 1.332. 1.332 volts. Okay? Now, the first question has to be, what happened? 1.332 is not equal to 2. One other thing we might want to check is 1.332 equal to the sum of these three? And we can kind of eyeball that. Here's a little more than 0.6 and a little more than 0.4. 0.6 and 0.4 is 1. And there's a little change there, so, you know, maybe maybe 1.07 or 1.1, I don't know. And then if we add 0.25, I got 1.07 and 0.25, so that'd be 1.32, so right there. So these three total up to that. So that's encouraging, at least. Kirchhoff's law holds there. So it kind of goes to this question up here. What did you actually measure? You didn't measure peak voltage, right? Didn't measure. Now, what? I don't know why these copied up here, because they shouldn't. Make sure when you fill yours out, they don't copy. I hate to see that. Okay, that should be deleted. I hope I haven't made the form out. Oh, look, somehow these are connected. All right, I'll either send you a new form or what was it, 0.25. We can't have that. There's something wrong with the way I made the form. Okay, so I'll send you a new form where these fields are not independent. Obviously, that's a problem. So just write these down on paper, and you can come back to that. Now let's get the current. And the current we got to do in the old-fashioned way, and that's just picking the dial. And I'll start with milliamps, because I know it's going to be small, but, oh, and remember, there's only one current. So whatever the current is, we only got to measure it once. Okay? So I got to open up the circuit, which I'll do back here, where it's kind of easy. I moved one of the resistor legs. And now I'm going to measure AC current. And here it comes. Oh, it's 0.1. That's pretty small. So let me go down to microamps and see what I get there. Still pretty small. Oh, I'm back on DC. I don't want that. I got, a very small number. I'm going to have to check why that is. Okay, well, the problem is solved, and you all can get a good laugh at that. You were probably watching me. I failed to move the red probe from volts, ohms, over to amps. Now, I know I'm not dealing with full amps, so I put it over on microamps and milliamps, and I've started with milliamps like I tried before. And remember, I'm just completing the circuit with this. So it's not giving me much in the way of milliamps. Oh, that seems odd. Oh wait, I'm on DC. You can see with this meter, if you don't get the right AC or DC, if you have DC and you're measuring AC, it's going to give you zeros. So it looks like I got, maybe 0.1 milliamp. So that means I'll dial it down. And don't forget to go to AC. And let's see what we get. 113.6 microamps, right? So over here, we're looking at why didn't it let me do that? Here we go. 113.6, and I'll just use a little U, microamps. Okay? Now that's going to be the same value everywhere here. Right? So you can just take that value and copy that thing, paste it in there, paste it in there, and paste it in there. Okay? So these are good measured values. And then you can go back. Again, I'll have to fix this. So let me send you a new template. But you can handwrite them in for the moment. And these are measured values. So why didn't this match up to that? The reason is because the multimeter is measuring RMS, not peak. And when we had that initial discussion, oh, I owe you those PowerPoints. So I'll put that together too and send it. The relationship between this RMS value, which we're going to explore in the next video, RMS value and the peak value is 7/10. So let me just do, while you're here, I'll pull up the calculator, and if I take 1.332 and divide it by 0.707, right, I will get 188. And that's not quite 2, but that is that little bit that's short of the other thing. Another way you can get this is you can say, what if I had 2 and I multiply it by 7/10, or that 0.707 thing? I get 1.414. So if all that means is if this had stayed at 2 volts, this number would have been 1.414 instead of 1.332. But all of that is because there's a little resistance in here. So if you need to listen to that a couple of times, okay, but don't get too hung up on the fact that a few tenths of a volt got lost back here, like about 1/10. So that's all within experimental error, okay? I'm going to post this, and I'll be back with the last part of Lab 10, where we cover doing this thing as though it were a DC source. So here's that 1.414 volts, and I'll set this up with a battery. Actually, I'll use the oscilloscope and set it up as a DC source instead of AC, and we'll see how this goes. Okay, so this one you might want to follow because you got to write a little bit more, and you got to write a little bit more down here, and then like last week you're going to attach your picture right there. So we'll be back with part 3 of this. Thanks.